Hello and welcome to the July Wednesday webinar from the IEA Clean Coal Centre. My name is Benedicta Brox and I'm the Communications Officer here. Our monthly webinars are based on our technical reports available from our website www.iea-coal.org. Residents of member countries and employees of sponsoring organisations can download our reports at no charge after a one-off registration. Please visit our website for details. The subject for today's webinar is Highlights from CCT 2019, presented by Toby Lockwood. Take it away, Toby.
Thanks, Benedicta, and hello to everyone listening to this webinar, which, as Benedicta said, is on our biennial flagship conference called the International Conference on Clean Coal Technologies, or CCT for short. This was held in Houston, USA last month. My name is Toby Lockwood. I'm a senior analyst here at the IEA Clean Coal Centre, and I'm also program coordinator for this conference. Today I'm going to give a brief snapshot of some of the work presented at the conference and help provide an update on what's going on in the world of coal research to anyone who was unable to attend the event, or even introduce things that those of you who were there may have missed. And I'm just trying to work out how to change slide. Here's a brief overview of the things I'm going to cover. Some of the key topics at the conference include some regional perspectives, trends in high efficiency power plant, developments in CCS, pollutant controls, and some other highlights I've picked out. So let's give a quick overview of the conference. Like previous editions, the conference was attended by a broad range of delegates from around the world, representing industry, academia, government, and non-governmental organisations. Our remit with this conference is to cover any research, development, or demonstration of technologies which can help enable the cleaner exploitation of coal, as well as related issues such as policy, social acceptance, and financing. This year, we were very pleased to have the US Department of Energy's Office of Fossil Energy as our co-hosts, combined with logistical support from the United States Energy Association. The selection of Houston as our venue obviously allowed us to offer delegates visits to two world-leading projects in carbon capture and storage, namely the Petronova and Net Power demonstration projects. And the conference website is at the bottom there. So here's a brief overview of the technical sessions we cover at the event. They can be broadly divided into three streams: high efficiency, low emissions plant in the top left, developments in CCUS at the bottom, and sort of other topics on the top right, including non-energy products from coal and coal waste, biomass co-firing, and sustainability related issues such as social acceptance and water consumption. We also had some great keynote speakers and plenary session speakers, including Lou Huckman, the Deputy Assistant Secretary of Clean Coal and Carbon Management in the US, Executive VP at China Energy, Director of Engineering at NTPC India, Greg Kennedy, the Project Manager for Petronova at NRG, and Dave Begley, who's Steam Power Managing Director of Steam Power for the Americas at GE Power. Lastly, we featured a couple of expert panel sessions, one on driving CCUS deployment in the US, which I'll come to later, and another one featuring international R&D program leaders discussing future directions for their research. So I'm actually going to start with a slide from one of the closing talks, which was an overview of coal's place in the global energy mix given by Dr. Ken Medlock from the Baker Institute at Houston's Rice University. Many of you will know this, but it bears emphasizing that coal's share of total primary energy demand worldwide has remained remarkably constant since 1985. And given that energy consumption has almost doubled in this period, this represents an absolute increase in coal consumption, which continues on a year-on-year basis to this day. It is therefore very likely that coal will remain a significant part of the energy mix for decades, and there's an urgent need to ensure it can be exploited as sustainably as possible. This theme came up in several talks at the conference. Next, I'll look at some of the regional overviews provided by our keynote speakers and others. To go from the conference close to its start, we kick things off with a keynote from our hosts, Lou Hookman of the DOE. The US DOE has long been a strong supporter of coal technology development and at all technology readiness levels, and has current areas of focus on CO2 capture, utilization and storage, novel fossil power plant technologies such as fuel cells and chemical looping, and a cross-cutting program which looks at overarching issues such as water consumption, materials design, and computer modeling. Most recently, the DOE has put funding towards the Coal First initiative, which stands for Flexible, Innovative, Resilient, Small, and Transformative. This intends to drive development and innovation of entirely new concepts in coal power based around small modular plants which can respond rapidly to grid demands and are integrated with carbon capture. The CCT program featured a huge range of new coal technologies being developed either by contractors to the DOE or the DOE's own National Energy Technology Laboratory, some of which I'll mention later. In China, the China Energy Investment Group was formed 2 years ago from the merger of two energy giants, the Shenhua and Guodian groups, and is now the world's largest power company by installed capacity and also the largest coal producer. Mr. Mi Shuhua, the Executive Vice President, gave an overview of their extensive activities in the coal sector, which was supported by more technical presentations throughout the day. China's primary energy consumption is expected to continue growing to 2050, and while coal's share of the mix and absolute output will eventually decline, it remains the largest single source of energy even then. In the power sector, China Energy has been at the forefront of developing and deploying some novel technologies, including building the world's first 1,000 megawatt double reheat units, shown here at Taizhou 2, achieving ultra-low levels of SOx and NOx, which I'll discuss later, developing large-scale CCS demonstrations first on a coal-to-chemicals plant and more recently at the Jinzhou coal power plant. Other work includes deployment of ultra-supercritical circulating fluidized bed units and the development of solid oxide fuel cells powered by coal syngas. Which brings me to Japan. Speaker from NEDO, or the New Energy and Industrial Development Organization, which is an arm of government, it gave an overview of the policy background and current areas of R&D interest in Japan. And a familiar trend, coal share of the energy mix is expected to slightly decline to 26% in 2030 as the country seeks to reduce dependence on imported natural gas while reinstating some of the nuclear fleet, which was previously shut down following Fukushima. NEDO have a particular interest in integrated gasification combined cycle and also integrated gasification fuel cells, both of which technologies are being demonstrated at this Osaki Coolgen plant, shown here. This site is based on oxygen-blown coal gasification developed by NEDO and has been operating the IGCC component since 2016. A pre-combustion carbon capture facility will start this year, and the fuel cell pilot, which obviously runs on hydrogen derived from the coal syngas, is expected to start in 2021. This is anticipated to achieve 47% efficiency, higher heating value. India was ably represented by its largest power company, NTPC, and leading equipment manufacturer, BHEL. Massive renewables growth is planned in India, while coal remains the backbone of the dispatchable support for these variable sources of energy in 2030. India has made a goal to use more of its domestic coal in the place of imports, but this fuel is high in ash and can pose a series of challenges for technology providers. The drive towards high efficiency plant has perhaps been slower than that seen in China over the last 2 decades, but NTPC recently commissioned the country's first ultra supercritical plant at Kargoni and has 2 more under construction scheduled for 2020. There's a strong focus in India on developing even more efficient plant in the form of advanced ultra-supercritical plants, potentially aiming for a fleet of around 10 of these. NTPC is also engaged in major upgrades to its existing fleet, notably the testing and rolling out of SOx and NOx controls to meet more stringent emission standards, which were introduced a couple of years ago. So now I'm going to look at some of the technical sessions, starting with high efficiency developments in high efficiency power plant. Firstly, Shanghai Shenergy, a Chinese company which are best known for a series of advances in efficiency optimization and plant maintenance, made at Waigaoqiao power plant, which set a number of records. Building on this success, they proposed an innovative plant design which reduces the cost and efficiency losses associated with the high pressure steam piping by elevating the HP turbine to the level of the boiler superheaters. You can see this on the left here. That was first introduced at the previous CCT, and it's now a demonstration of it is currently under construction at the Pingshan 2 power plant, which is a 1,350 megawatt unit, which is expected to begin operations next year and has a targeted efficiency of over 49%. At this CCT, an extension of this idea was presented in which the entire turbine and generator is elevated. This is to also eliminate the reheat piping and avoid the complications of controlling two turbine shafts separately. So obviously minimizing the high pressure steam piping also provides a more straightforward or lower cost route to using more expensive higher temperature materials. So the new design is to be implemented at the Fuyang power plant owned by China Resources Power, this time in the form of two 660 megawatt double reheat units. These smaller units have been chosen as more practical and more widely marketable than the huge unit used at Pingshan. But the efficiency of these units is still expected to surpass that of the Pingshan project. Shenergy also gave a second fascinating presentation on significantly raising the efficiency of existing subcritical units by increasing their steam temperature to 600 degrees while retaining as much of the boiler's original heating surface as possible. This is also being demonstrated at a full-scale plant called Suzhou, which is currently under construction, and the targeted efficiency there of 42.8% would be even higher than the existing supercritical fleets in China. So a lot of interesting work done there. There's an ever-increasing trend towards greater digitalisation of new and existing coal power plants involving, this really involves obtaining more accurate data and more data from the plant, implementing techniques from data analysis, using more advanced control systems and simulations. These ideas were very much in evidence across a series of talks at CCT, a few of which I've highlighted here. Mitsubishi Hitachi Power Systems presented their intelligent control system, which uses the company's extensive operational experience to simplify and automate the vast parameter space involved in optimizing the power plants to minimize emissions and maximize efficiency. A representation of this concept is shown on the slide here. MHPS also presented their future vision of using remote centers around the world to help tune power plants from a distance. Tata Consultancy outlined its development of the increasingly prevalent idea of using a digital twin. This is where a realistic computer model of the plant is used to assist in control, make predictions, provide additional data through simulated measurements, which are called soft sensors. This concept is also used in GE's quite well-known plant digitalization package. This claims to offer a 1.5% efficiency increase, as well as a 3% increase in plant availability through more targeted maintenance. Lastly, the research arm of China Energy, known as NICE, showed how its power plant smart management system could optimize a combined heat and power unit. This minimizes the detrimental effect of load following, which is increasingly an issue in China, and also reduces the cost penalty incurred by selling overly high-grade steam for district heating. So the next frontier in power plant efficiency is the development of AUSC technology, which uses nickel alloys in parts of the power plant to allow steam temperatures of over 700 degrees and targets efficiencies of over 50% lower heating value. The US has a long history of research in this area, with current efforts known as the COMTEST program. This is a research consortium of organizations including EPRI and GE, and is headed by the Energy Industries of Ohio. EPRI presented the achievements of the completed COMTEST Phase 1 and the aims of the recently approved Phase 2, which is now focusing on full-scale fabrication of nickel alloy components and the development of a domestic supply chain for these parts. Key components which will be fabricated and tested include the turbine rotor, superheater and reheater headers and tubing, and steam piping. Pictured here is a design for a steam turbine nozzle carrier to be cast in Haynes 282 nickel alloy. In the Envision plant, grade 91 steel is used for boiler water walls, Sanarco 25 steel and superheated tubes, nickel alloys such as Haynes 282 and Inconel 740 for large tubes, and forged or cast components such as the turbine casing and rotor. As mentioned earlier, India launched its own AUSC development program in earnest in 2017 and is now approaching completion of an initial 2.5-year R&D phase, which, if all goes well, will be followed by construction of an 800 megawatt demonstration plant. Led by NTPC, BHEL and the country's Atomic Research Centre, this initiative is looking at similar materials to the US program, as well as nickel alloys such as alloy 625 for the turbine casing, which is pictured in manufacture here on the right. Test facilities for tubing, corrosion and spinning turbine rotors at high temperature have been in operation in India. Another promising route to higher efficiencies is the use of supercritical CO2 as the power plant working fluid in the place of steam. As well as generating more turbine power for a given temperature change, this fluid allows for much more compact machinery and greater use of low-grade heat. A leading example of a CO2 cycle is the Alum cycle oxy-fuel concept, currently being tested at a 50 megawatt thermal scale just outside Houston. Although this plant operates on natural gas, at CCT, the parent company 8 Rivers Capital presented an update on their version of the cycle based on coal-derived syngas. They have been tackling issues related to the switch in fuel, including corrosion tests, acid gas removal, and adapting the combustor to syngas. The coal-based cycle is expected to still be capable of a remarkable 50.3% net efficiency, while also delivering storage-ready CO2. An alternative concept presented was the indirect CO2 cycle being developed by a DOE-funded consortium led by GTI, known as the STEP project, standing for Supercritical Transformational Electric Power. This process transfers combustion heat to an isolated CO2 working fluid, as opposed to the Alum cycle where the CO2 is generated by the combustion itself. The STEP project is currently constructing a 10 megawatt electric test facility at the Southwestern Research Institute in San Antonio, which is expected to start testing in mid-2020. It's worth noting that supercritical CO2 cycles should also be able to benefit from the new high temperature materials which are being developed and verified by the AUSC program. I'm now going to turn to the other major topic of the conference, which is carbon capture and storage. As mentioned, just outside Houston at the WA Parish coal plant is the world-famous Petronova CCS demonstration plant, pictured here on the right, which became the largest coal power facility with CCS when it was commissioned in January 2017. Here I'd like to focus on the solvent-based capture technology used at this plant, developed by Japan's MHI, who presented their latest improvements on the Petronova technology at CCT. This is called the Advanced KM Carbon Dioxide Removal Process, and it uses a new solvent known as KS21, whose properties are shown here alongside the KS1 solvent used at Petronova. Reductions in volatility and degradation are most notable here, which allows reduced solvent consumption and regeneration at higher temperatures and pressures, which represents an energy saving. However, major cost savings of 30% are also due to a more compact plant with reduced design contingencies, such as the absorber isn't as tall, and more modular fabrication methods, which is a recurring theme in CCS at the moment. Some of the real highlights of the CCS sessions at CCT also came from the International CCS Knowledge Centre, which I'm sure you know is a Canada-based research group born out of the pioneering first CCS power plant built at Boundary Dam in Saskatchewan. So as well as reviewing the latest data from Boundary Dam, the group presented their recent detailed feasibility study for a new CCS retrofit at Sask Power's Shand power plant. This work has produced remarkable results, showing a 67% reduction in capital cost over the older plant on a cost per tonne of CO2 basis. This is attributed to lessons learned from Boundary Dam, larger scale and modular construction techniques, again, an improved integration with the steam cycle at Shand, which is slightly more amenable to CCS retrofit. Along with operating cost savings, these contribute to a highly competitive capture cost of $45 per tonne of CO2. Other features of the design presented include its zero net water consumption and a lower overall CO2 intensity than power produced from wind with natural gas peaking plant. I'd encourage anyone interested in carbon capture to take a look at the full reports. As I mentioned at the start, we also held a policy-based panel discussion to reflect the major new incentives in the US which could help make CCS a commercial reality in the next few years. Most notably, the famous 45Q tax credit introduced last year, which provides companies with a credit of up to $50 per tonne of CO2 they store. I'm grateful to Holly Crooker at Peabody for inviting an eminent group of panelists to discuss this topic, representing the DOE with its vast CCS development program, Occidental, who are leading the way in deploying new CCS projects for enhanced soil recovery, and the Carbon Utilisation Research Council, which helped push through this new legislation. So early signs of 45Q inspired investment are mostly linked to EOR and easy to capture sources of CO2 such as bioethanol plants, but there are apparently other developers waiting in the wings for a clarification of the new tax code from the IRS. The deadline of the credit is somewhat tight, requiring start of construction by 2024, but there is hope it will be extended. In another presentation from capture technology developer Ion Engineering, we saw real evidence that the new legislation is making a difference with the company's plans for full-scale demonstration at a plant in Nebraska, which are carefully laid out to meet the deadline. As you can see here, this is a Ion Engineering user low water content solvent. So while the full-scale demonstration of these mature CCS technologies is of huge importance, there are also a vast number of new innovative capture technologies being developed, particularly in the USA, which were featured throughout the conference. Oxy-fuel combustion is still a going concern. We had an update from IHI, who are famous for developing the technology used at the Callide oxy-fuel plant in Australia. But in the US, at least, the focus is on pressurized oxy-fuel concepts such as this flameless oxy-fuel process, which was originally developed in Italy and is now being studied by the Southwest Research Institute in Texas. This system improves heat recovery from the flue gas, increases combustion efficiency, and reduces system size. So the Institute is designing and costing a potential pilot plant, which could be located at the University of Wyoming's Central Energy Plant. And there's a design of the test loop focused there, pictured there. On the right, chemical looping combustion. There's a packed session on chemical looping combustion at CCT. This technology offers a route to producing pure CO2 without the energetically demanding gas separation step you normally find in CCS. This session included work by Ohio State University, Reaction Engineering, and NATL. Here you can see the 50 kilowatt thermal test rig of the Instituto de Carboquímica in Spain. They detailed their work in CLC with integrated coal gasification, which includes increasing capture rates and reducing oxygen demand through innovations such as improving the gas-solid contact in the reactors and feeding coal to the carbon stripper device, which essentially making it a secondary fuel reactor between the air reactor and the fuel reactor. So turning now to more conventional pollutant controls, some of the most striking results are presented by China Energy, where air quality concerns have famously driven strict emissions legislation in recent years, mandating an ultra-low emission standard across the coal fleet, which matches those required by gas-fired units, shown here in the table. But China Energy have also developed a near-zero emissions design represented by the Ledong unit in Hainan province. This achieves the minimal emission levels shown here in red. This is largely through deployment and optimization of existing technologies such as SCR, wet FGD, and a series of particulate filters, as well as things like pre-treatment of the coal. Some other interesting talks shown here included Imogen's detailed modelling of dry sorbent injection for SOx and HCl control, Thermo Fisher's work on accurately measuring ammonia slip using tunable diode lasers or chemiluminescence, and a new multi-pollutant control system which is being developed and scaled up by Nurion in Sweden. So the US was an early mover in introducing legislation and control technologies to counter mercury emissions from coal plant, and other regions such as Europe and China are now following this lead. At the very low levels required by mercury legislation, accurate measurement becomes a serious issue, and Ohio Lumex examined the trend towards using sorbent traps for this purpose, as opposed to the continuous emissions monitoring systems which were originally adopted. Joint work by Wrocław University in Poland and CTU Prague studied the capture and emission of a mercury species throughout a full-size lignite plant, finding a high sensitivity to a lot of factors, including fuel type, flue gas temperature, pollutant control type, including surprisingly high levels of mercury escaping from the wet FGD, which is due in part to impurities in the limestone slurry. So this kind of plant is likely to need further control technologies to meet the new EU limits, which come into force from 2021. Finally, I'm going to present a last couple of slides with other subjects which were fairly new to this edition of the conference. Firstly, there's growing interest in the direct use of coal as a feedstock in carbon-based products. These are using approaches which generally contrast with the traditional gasification or liquefaction-based route to chemicals, which was also extensively covered in sessions at the conference, but I don't have time to go into here. Unlike those methods, this approach frequently offers a low CO2 route to deriving value from what's really a hugely abundant and low-cost source of carbon. A company called Sem Plastics have developed a composite material made from coal powder mixed with polymer, which can be used as an alternative for ceramic tiles or graphitic anodes in lithium-ion batteries. Another interesting idea was presented by ArcTech, whose coal biorefinery process uses an enzyme which is actually derived from the guts of termites and can break down coal into humic products, which are used in agriculture. This has been tested at a few pilot facilities around the world and could also be applied to unminable coal seams to derive value from those sources of coal. So as a sort of extension of this idea of converting coal to new products, we saw the same approach taken with coal waste, which in the US, as for many countries, is a significant resource. One of the most interesting ideas in this vein is the extraction of rare earth elements, which can be found in varying concentrations in waste products such as coal refuse, tailings, acid mine drainage, and power plant ash. The graph on the left shows concentrations of rare earth elements or yields of rare earth elements in various types of US coal. And coal waste from those coals. As you probably know, these rare earth elements are increasingly vital for an array of applications, including batteries, lasers, satellites, and the US is seeking to reduce its reliance on imports. Under a DOE program, a number of universities have developed pilot facilities for rare earth element extraction, including West Virginia University's work on acid mine drainage, which is pictured here. They treat the drainage to produce a sort of sludge into which the elements precipitate. And this achieves nearly 100% recovery of the elements. The next challenge is scaling up this kind of process to produce significant quantities. So I can't finish without mentioning the final day of the conference, which gave delegates the opportunity to visit the Petronova and Net Power facilities. Petronova obviously is shown on the right here, and Net Power on the left. Many thanks to our hosts, NRG and Net Power, for supporting such a large crowd. I've already touched on these during the presentation, but both projects are really at the forefront of large-scale CCS deployment. We had a fascinating tour of the Petronova facility, allowing a close-up view of the capture plant. The fact that the facility was temporarily shut down was due to a landowner suspicion of a CO2 leak, which turned out to be false, but it was an interesting illustration of the kind of everyday challenges associated with operating this kind of project. Lots of potential reasons for shutting down, not all of them valid. But the project's been operating very successfully. Despite this, NRG are cautious about launching another Petronova, partly due to the tight deadline on the 45Q legislation mentioned earlier. Net Power's alum cycle achieved first fire around a year ago to much fanfare, and it's currently undertaking testing of the turbine component. An interesting feature of this plant is that the combustor is already at full scale for the planned next step of 300 megawatt power plants. The turbine shell requires scale up by 2.5 times. The company is aggressively targeting commercial operation of these larger 300 megawatt plants by the early 2020s. So with that, I'd like to thank everyone for listening, as well as thanking our hosts in Houston, our sponsors shown here, and anyone who presented and attended the conference. My apologies if your work didn't make it into this brief summary. Further reviews of the event are available in the form of blogs from me and my colleagues on the IEA Clean Coal Centre website, and all the presentation slides are available from the program page of the conference website. These are only available to delegates for the first 6 months, and then they'll be made available to the general public. I hope you can all make it to the next event in 2 years' time. I'll just see if we have any questions. Not entirely sure how to do that. So someone's saying we can't see the bottom of the slides, which is unfortunate. What's the capture cost per ton at Petronova? They don't release that information, I'm afraid. That's from a guy who was originally scheduled to talk. Sorry, he couldn't make it. Yeah, unfortunately, they're very guarded about economic data at NRG regarding Petronova. Although if you get in touch with me, I might be able to provide what data we have, which is largely technical. Someone's asking when our next report on CCS will be produced. I think there's one vaguely in the pipeline, which will be a kind of high-level overview, perhaps covering some of the material I've mentioned here, but I wouldn't like to put a date on that. I'll get in touch. Or please do get in touch if you'd like further information. So yeah, nothing too unfortunately. I'll just give you a little bit longer to see if there's anything else. But yeah, sorry, I can be slightly more informative there. So just while we're waiting, I will say to close that these slides will be available to download from the webinar page of our website, and the next webinar will be on the 14th of August at the same time, 12 p.m. And that will be called Finance for Coal-Fired Power Plants, a really fascinating and topical subject, be presented by Mo Udin. So thanks everyone for joining us today, and goodbye. Someone's got another question in there. How many commercial scale CCS for coal now in operation? Simple answer to that, 2 basically, both mentioned today, the Boundary Dam plant in Saskatchewan and Petronova. But yeah, we could perhaps see more being developed in the US due to the new legislation. I mean, it depends a bit on how you define commercial scale, of course, but I think yeah, those 2 are largely recognised. Certainly on coal power, I guess there's some on others on coal to chemicals. But yeah. So I think that's our time, and please do get in touch if you would like any more information. Okay, we've got another question here. Keep trying to close. That's fine. Is CCGT CCS seen as more likely than coal CCS? It really depends on where in the world you are. In the UK, there is a definite focus on shifting focus towards gas-fired CCS, which is evidenced by some of the more recent projects being proposed in the UK, where there's quite a lot of kind of renewed interest in CCS. But in the US, I'd say the focus, at least in the power sector, is still on coal. And certainly in developing countries and areas that are hugely reliant on coal, such as China, there's no talk of gas CCS. So there's really a huge regional sort of distinction there. Someone else is asking about CCS on the steel plant in the Gulf. Not really my area of focus, but my understanding is that plant, that full-scale CCS demonstration on steel plant, I think it's in Saudi Arabia, is operational. It could be Abu Dhabi, I forget. But yeah, that's a full-scale demonstration. I don't know if more are planned. Anyway, before I get any more difficult questions, I might have to close. And given the most of them from the same people, please do get in touch. So goodbye, everyone.